It's fixed.
Is it?
Hello.
It is fixed?
Yep.
Great.
Oh yeah, it's much better.
Excellent. That's the old turn it off and turn it back on again. Great. Love that. All right, let's get back on track. So we have height of 75 feet on the triangle, base of 50 feet on the triangle, and this is the riding area. All right, now let's take a look. All right, so everybody can see it? Oh.
Yeah.
We can see it.
Admit all. There's still people in the waiting room. We don't have all of our 62 people. Admit all. Okay.
We
Now,
only have 39.
it says that the area of this triangle is going to be the diameter of the semicircle.
Which means that the radius of it is 25.
They want the total area of the pasture, which includes both areas. You guys have to pay attention to a lot of stuff. Okay?
How could something squared be the same as something like?
It means the value, the numerical value.
Oh, so like if the area was 3, then
That's a great question, though. So the area of this is going to be 1/2 base times height. Okay, and then basically it's 25 times 75. Okay, so this is a square footage area of the triangular riding area. Okay, 42, so 20 people did not get back in yet. That is a shame. But I will be posting this on YouTube, so that'll be okay. All right, so now this area is going to be used as this diameter. So this diameter is 1875. This is a half circle, so we need pi. The area of the grassy will be pi r squared over 2 because it's a semicircle. But I don't have the radius. Okay, so the radius is going to be half of this, which is what? 937.5. I think you're okay now. I don't think it was a bandwidth issue. I restarted my computer and everything worked fine. Yeah. Okay, so the radius is 937.5 feet, which is half the diameter. Now I can use that in my formula. So I have pi 937.5 squared over 2. Exponents first. Okay, we're finding the area of the grassy region. Okay, so 9. Uh-oh. You guys still there?
Yeah.
Something popped up on Zoom.
Yeah.
I don't know why. Okay. Okay, so I have 937.5 squared. Okay, big number. Times pi. I'm going to use 3.14. Make a note. Use, these problems look just like your test. So these should all be sections that you can go to problem for problem, right? This problem you're going to have next to you while you're doing this problem. See what I mean? Come on, guys, you can do this. You can make this work. Okay, make that note. Then if you're taking notes properly, I'm going to know you took notes properly because I'm saying now use 3.14 for number 7. Okay, now equals, even bigger number, divided by 2. So I'm in the millions now. So I have, this is approximately 1,379,882.8 square feet. Okay? And then they want the area of the entire pasture. So I have to add the 1875 to that. So I'll take this. Oh, and I need to round this. 0.9. It says round to the nearest 10. Okay? And now I'm going to add the area of the pasture plus 1875. Well, that area seems so insignificant. So I guess the grassy area is a ginormous field, right? Not drawn to scale. This is some giant field. And then this is just a small writing area on there. So then my final answer is 1,381,000. That's that extra almost 2,000 added on. 757.8. I guess it would be 0.9 because we had rounded. Let me just double check everything. I want to make sure we did this right because these numbers are a little big. Okay, so it said a horse pasture is formed by a large semicircular grassy area. They weren't kidding when they said large, and a triangular shaped riding area. The base of the riding area, 50 feet, height of 75 feet. The total area of the pasture. What is the total area of the pasture if the base area of the riding area, the base area of the riding area, the base area of the riding area. What does that even mean? I feel like they didn't write this question very well. I'm saying the area of the riding pasture equals the diameter. So I got the area, 1/2 base times height, equals the diameter of the grassy area. So we use that. We got the radius, that's right. And then the area is pi r squared is for a full circle, divided by 2 is a half circle. Okay, we plugged that all in. And then we added the total area, which includes the triangular riding area. Just making
What does it say that the diameter is for the grassy?
It says the diameter is whatever we got for the area of the triangle. That's how I'm interpreting it. It says, what is the total area of the pasture if the base area of the riding area equals the diameter of the grassy area? I don't know what they mean by the base area of it. All I can interpret is the area of it. Okay.
Maybe they're talking about like since the floor of the writing area is the area that you're gonna find. That would be.
I guess it's the area on the ground area of the writing area. They should have just said writing area. Anyway, this is your answer. Okay, so now you know when you're taking the test, you're going to get something large. All right. We're going to move on for time purposes. Any questions before we move on?
Question.
Uh-huh.
How'd you get from 0.9 to 0.8?
It should be 0.8. I didn't round it in my calculator. If I would have rounded it to 0.9, then that would have been 0.9.
Oh, okay.
Okay. All right. Any other questions? Let's go back to the share screen.
Wait, how did it become 0.9?
I rounded it. I think I got 0.88. I mean, I could do the calculation again.
When I did it, I got 0.81.
Okay, yeah, let's see. Maybe it is. 937.5 squared times 3.14 divided by 2. 1379882 point. You're right, it's 0.81. So it should be 0.8. I don't know why I thought I saw 0.88. Oh, I was looking after that comma. I saw 88. Okay, so it is 0.81. It's 0.8. Okay? So that's the answer right there. That's adding the triangular area to it. I'm not impressed with the problem myself, okay? And I'm going to take things like that into account on the grading, folks. All right, so just remember that. My grading, I'm going to try to award as many points to you guys at the end of the year here. I'm going to try to give out presents to everybody here, okay? I know it's difficult, but I want to reward you for working hard through this. So don't give up. Work as hard as you possibly can, and I'm going to do whatever I can to give you as many points as I can, above 100% if I can, to try to get anybody who's trying to reach that next grade up the opportunity, okay, or people that are trying to maintain their grade. Okay, let's go on to the back side. So that was a difficult front side. Back side. This is going to ease up a little bit. So now we're on number 8. Erase my board here. Okay.
Octagonal prism.
So look, you're going to get questions like this. It won't be an octagonal prism. It'll be something else. Okay? Hold on, let me get this one thing out of the way here. Okay, so look at these questions. 8, 9, and 10, and 11. These are not as brain busting. You can look it up if you needed to. But why? You get the idea now in your head, so you don't have to. Remember, you don't want to spend time that you're going to need for other stuff. You want to zoom, no pun intended. You want to zoom through this part. So look, number 8, identify the figure shown by name. What are the 2 things you need to name it? Is it a 2-base object or a 1-base object? If it's 2 bases, it's a prism. If it's 1 base, it's a pyramid. Okay, or a cone, okay? Now, how do you name that prism? This one has 2 bases. That makes it a prism.
You count the number of
Hold on, wait,
sides.
one second. We know it's a prism because it has 2 bases, so prism should be in your answer. And then you look at the base. What kind of base is it? What is the polygon that makes it? Well, that's an octagon. So you're going to call this an octagonal prism, okay? So if you want to switch to my screen, octagonal prism. You won't get an octagonal prism. Octagonal. Got to put the emphasis on the right syllable, right? All right. Any questions about 8?
We just did that with Miss Kincaid yesterday.
Yeah. There you go. Cross-curricular. Any questions about number 8? That this is called an octagonal prism. Look at that. You get a point for that. How many vertices and edges make up the figure? So I want you to separately tell me how many vertices and how many edges. It's just counting. So for vertices, you have 8 on the top and 8. Hold on. You have 8 on the top and 8 on the bottom. So this one you have V equals 16. I'll know what you mean. That's how I want you to answer. So vertices is 16. Edges. You have 8 edges on the top, 8 edges on the bottom, and 8 lateral edges. So you have 24 edges. So E equals 24. Okay? So if you want to look at my screen, that's how I want you to answer.
Mr. Rosenthal,
Uh-huh.
what's a vertice?
It's the points. It's all the points that make up the object. The edges are the segments.
Okay.
Okay? Maybe it'll ask you how many faces it has. How many faces does this one have? Top, bottom, and then it has 8 lateral faces. So it has 10 faces. Okay? Any questions?
Do you think they would have like letters and then try and get you to name the vertices, or would it be a lot?
No,
more
it's going to be just like this.
Oh,
Yeah.
that's easy.
Mm-hmm. Number 10, identify the shape resulting from a horizontal cross section. So if I take a sheet of paper, and you need to know the difference between horizontal and vertical, of course. Make sure you write a little note to self. Horizontal is side to side. Vertical is up and down. So if I take a sheet of paper and I go sideways, slice through this in the middle of the object, right? And then I pick up the object and I stamp it in ink and then stamp that on a paper. What will the object be?
An octagon?
It will be an octagon. That's your answer. That's it. Number 10 is octagon. So this is your brain break. Don't take a brain break, but compared to the other problems, this is a load off. Okay, now.
Wait, Mr. Rosenthal, if you took out paper and you did it like horizontally, it wouldn't be an octagonal prism anymore because.
No, it would be, okay, so when you do a cross section, you lose a dimension. So now you can't have a prism, you're gonna get some sort of polygon.
Oh, okay, yeah, I get it.
Yeah, and the polygon is whatever the base is. When you do a horizontal, it's the same as the base. If you do a vertical, what would you get? You're gonna get a rectangle. Yeah, it's gonna be a rectangle. All right, okay, now, number 11, draw a view, a side view and a top view, okay? So a side view is if you are, pretend this is a building and you're standing in front of one of the rectangles. A side view of this, you will not see any depth, okay? So if you are looking at a side view, you're gonna be looking at this and these like that. This is a side view. So just look at the front of the octagon. If you're looking at the front of the octagon, these have depth to it, but you're not shading it like an artist. All right, you're not giving it any depth. A side view means you're just looking at it from the side. Okay, and maybe these are a little bit smaller because they're going away from you. But that's what you see from the side of this octagonal prism. And then they also want a top view. Well, the top view is going to be an octagon. You're just looking straight down on it. You're just going to see an octagon. Oops. So this is the top view. This is the side view. Questions about that?
Mr. Rosenthal.
Mm-hmm.
So, you don't have to draw a perfect, like let's say you get a hexagonal prism on the test.
Mm-hmm.
It's fine if you don't draw a perfect hexagon, right?
Make it the best you can.
Okay.
Any other questions about number 11? Okay. Well, I'm surprised. Some people might have trouble with the drawing of that. Okay, now let's jump back in to number 12. Everybody start looking at 12. A jeweler has 3 solid gold cylinders. So guess what I'm going to start drawing? I'm going to start drawing cylinders. Solid gold. Jeweler has 3 solid gold cylinders with radii 4 millimeters, 6 millimeters, and 8 millimeters. I'm going to draw those. You draw them too. Draw them bigger each time. Okay, and one of them has radius 4, 6, and 8. Each cylinder has a height of 20 millimeters. Oh, they're all the same height. Okay, I'm labeling that. If the jeweler melts the cylinders down to make a solid prism with a square base of length 10 millimeters, I'm going to start drawing that. I'm going to draw a square prism, which is a cube. Base 10, side length 10 millimeters. Oh, it's a solid prism. The height we don't know is 10. That's what we're going to find. What will be the approximate height? Okay, so I have my picture. Okay, 3 solid gold cylinders, 4 radius, 6 and 8, all of them 20 millimeters. We're gonna melt them down. This is not a surface area problem. It's a volume problem. Okay, so I wanna get the total volume of the 3 cylinders melted down into one volume. Okay, so what will the volume be? Volume is area of base times height. Make sure this is in your notes. Okay, well, the area of the base is pi r squared. It's a circle. These are all circles. So pi r squared. So this one will be 16 pi, will be the area of the base times the height, plus this one squared is 36 pi times 20, plus this one is 64 pi times 20. Now you could factor out the 20 and multiply by 20 just once at the end. Or you can actually multiply by 20 each time. This one would be 320 pi. This one would be 720 pi. 20. This one would be 1280 pi. And I'm going to add those all up in terms of pi. Treat pi like x. 320x plus 720x plus 1280x. Your answer is going to be in terms of x, right? But this is in terms of pi. 0, 12, and 11, 13, 2320 pi. That is the volume that I'm going to get here. Okay, now I'm going to multiply by 3.14. Use the trusty calculator.
Mr. Rosenthal?
Yes.
How did you get 16 pi and 36 pi and 64 pi?
Pi r squared is the base area. So you have r, square it. What's
Okay.
4 squared?
16,
And then times pi. 6 squared
36,
times pi. 8 squared
64.
times pi.
Okay.
And then the 20 is the height in the formula. For
Yeah.
each one, it's the same. So now I have all these, and I'm adding up to get a total volume. And I'm putting in my calculator 2320 times 3.14. Can I get this? 7284.8. That is the total volume that I have. Now I'm going to pour that volume into this. Okay? What is the volume of this?
100
Area
times.
of the base, it's the area of the base times the height, right? Well, the area of the base is 100 times the height. And we're going to fill that up. And when we fill it up, it's going to fill it up with this much volume. So I can plug this in for V. 7284.8 is equal to 100 times H. What's nice here is I don't need a calculator because dividing by 100 just moves the decimal. Divide by 100 on both sides. The height must be, move the decimal twice, 72.848. And what we're going to do is we're going to round to the nearest tenth. So H is about 72.8 millimeters. That problem was not too bad. All of these problems are lots of steps, lots of understanding.
Why'd you do 100 times height?
What's,
Never mind. I understand.
got it? Okay.
Yeah, I missed it.
Other questions?
So, after we, in the problem on the test, if it was like the same thing where you added up all the numbers that came from the cylinders in terms of pi, you would, after you did that, you would multiply it by pi, right?
Yeah, I did, and that's where I got this number.
Okay.
This
Is that
one,
necessary?
yeah, from here to here is what I multiplied by 3.14. And then you pour that in there, and it fills that base up to a height of 72.8.
Where did the square come from? Was it in the problem?
It told me that it said if the jeweler melts the cylinders down to make a solid prism with a square base.
Oh, okay, okay.
Still
Did it say that it was 10 millimeters?
Width of length 10 millimeters. Each length is 10 millimeters.
Okay, okay. Alright, okay.
On the test, Mr. Rosenthal, so you said we should, on the test, we should show like all the work that you're showing right now.
Yeah.
Do we have to show the, like the 7,284.8 equals 100 H both
Yes.
over 100? Okay.
Because they're the same volume. It's just
Yeah, this volume came from that volume. He melted this down, or she melted, it doesn't say he or she. The jeweler melted down the gold cylinders, and that is the volume of them, and poured it into a square prism, and it rose to that height because it ran out at 7284.8. It ran out.
Would you suggest making it like a cheat sheet of the equations?
Yeah, oh yeah, please. And then not only that, you should have different sheets. Like this goes with number 12. When you do number 12 on the test, this sheet could be out next to you.
Body's being so nice to you. I can't believe it.
Mr. Rosenthal?
Yeah.
So where did the 7,284 come from?
Look right here. This is what I got from the different cylinders. I multiplied it by 3.14, the 2320.
Got you. Okay.
If these problems were easier, I would say, the note thing, taking the notes and giving you problems that look so much like it. Well, we did that anyway, right? It's still difficult. Don't take it for granted, all right? There might be little changes to the problems. Some of the problems really do look exactly the same, like number 14. It looks just the same, just with different numbers. Okay, let's go to number 13. Number 14 is a heck of a problem. I had fun doing it yesterday. I practiced it yesterday. I enjoyed it. But all you have to do is leave out one thing and you don't get that one. Alrighty then. Ace Ventura. Number 13. They just ask you this. They just throw out this question to try to trip you up. Are spheres polyhedrons?
It's a shape with infinite sides.
We treated it like a polyhedron with infinite faces. But since you cannot have infinite faces, then by the definition of a polyhedron, you have to have those planar faces. Each face has to be 2D. The sphere doesn't have that. So it's not technically a polyhedron.
It's a cone polyhedron.
So the answer to number 13 is no, because a sphere does not meet the requirements of the definition of a polyhedron.
It doesn't have bases or faces or vertices or edges.
Yeah, it doesn't have those things.
On the test, can we just write no, or do we have to write the explanation?
You must follow. That's something I cannot make clear enough. It's a problem that I have in all grade levels every year, always. It will always be a problem. Follow the directions to a T, to a perfect. If it says explain.
Oh, I didn't see explain.
If it says, I know, but a lot of students don't see that extra. You start doing the problem. I'm guilty sometimes of that. You must read the entire question. If it says to explain, you must have an explanation. The explanation is it does not meet the requirements of the definition of a polyhedron.
Mr. Rosenthal?
Could we just say that?
Yeah, that's fine. Or if you want to mention that it doesn't have faces, look up the definition of a polyhedron. Say that it doesn't have what the definition of a polyhedron is. It doesn't have those aspects.
Mr. Rosenthal,
Yeah.
You're saying that a sphere is not a polyhedron?
It's not.
Yeah, it's not.
I don't understand why though.
A polyhedron is made of polygon faces.
Yeah.
Vertices, edges, and faces where each face is a polygon. A circle has no polygonal faces.
because yeah.
Oh, because it's infinite.
Yeah. So because it has no polygonal faces, then it is not, doesn't fit the definition of a polyhedron.
And it also means that it has no vertices.
It has no vertices. Every point on it is a vertice, is a vertex.
Yeah,
And it doesn't have any edges.
because it has no faces.
Yeah.
Yeah. But it does follow, the formulas for it follow as if it were a polyhedron of infinite faces, vertices, edges. Okay? All right. Now we're on to probably one of the most difficult problems, is that box there. Okay? So the key to number 14 is picking apart every detail. Students will overlook the details of this thing. Good thing we're going to go over it.
Mr. Rosenthal,
Uh-huh.
I think we did this. We talked about it yesterday, but will we have to basically like assume the length?
You're going to assume that that is a half cylinder at the top of that.
Yeah, because it could be like a quarter.
That's all you're going to assume, I believe. Okay, so what I'm going to recommend to you is this. I'm going to break screen now to mine. What you need to do for this problem, number 14, top, bottom, right. Organization is key here. Left. What am I missing? Front. Back.
Back.
Do everything separately and add them all up. It's asking for the surface area. So here the publisher makes a mistake, by the way, in the answer key that the publisher gave. They gave a volume, and the question clearly states a surface area. So even the publisher got this wrong. All right, so here we go. What you want to do. Now, the hardest part of this is which one? The top, bottom, left, right, front, or back?
Top.
The top is the trickiest to understand. Then I would say the front and the back.
Yeah.
But the left and the right, easy. They're rectangles. The bottom is a rectangle. So let's go ahead and do the easy parts first. Okay, so the bottom, let's go back to the share screen. The bottom is a rectangle that's 30 by 50.
30 by 50.
30 times 50, and that's going to be 1,500. I'm going to put a little box around it. Bottom is done. See, we're all done, guys. That's it. We can move on. Just kidding. Okay, the right-hand side and the left-hand side are the same. So when you do the left, you can also do the right. So the left side is a rectangle that's what? 50 by what?
20?
Careful.
20.
Is it 20 or 30? Does the 20 go all the way to the top?
30. It's 30.
It's
Yeah,
30.
the 30.
It's 30 by 50 again. And so is the left, 30 by 50. And you got to keep switching back to my screen. So 1,500 for the right, 1,500 for the left. Okay, now we can start getting into a little bit more difficult territory. Okay, so let's do front and back. And here's what I'm going to show you. I'm going to draw it. And let's see.
And he might give you enough for the radius. Because the radius is 10 millimeters since 20 doesn't go all the way to the top. And it's like.
I need the area. This is the front and the back. Okay. I need the area of these pieces. Okay. You see that? I need the area of these pieces. So what was this dimension? This was 30 by, what's this? What's the height of this rectangle?
It was 30.
30.
No, it's not. Let's look again.
20.
If you go all the way to the top, it's 30. But the rectangle I have is cut off. It's at the 20 mark. See it?
It's 20.
Yeah.
Oh.
So this is 20. All the way to the top is 30, which means I know this dimension is 10. Okay? If that's 10, then the radius of the circle is 10. That's an important piece of information. The radius of the half circle is 10, which means that the diameter is 20. See that?
Mr. Rosenthal?
Which means that the width of each square is 5.
Mr. Rosenthal?
Yes.
How did you determine that the two little pegs sticking out were 10? You said you...
Because it said that this is 20, but the entire distance to the top is 30.
Oh, okay.
So that's 10. Okay. Now, if this all the way across is 30, and the circle takes up 20 of that, then what's left is 10 to be split evenly. 5 on this side, 5 on that side. Oh, here's the other thing you have to assume. This is 2.5, 2.5, 2.5, 2.5. Okay, now I can start grabbing the areas. Okay, so the area of this rectangle is 600. Okay, the area of this little rectangle is 2.5 times 10. So 25 here, 25 here. And then the half circle, how do you take the area of a half circle? Pi r squared over 2, right?
Yep.
So the radius is 10. 10 squared is 100, over 2 is 50, 50 pi. Okay, so this is 50 pi.
What did you say was 2.5?
If I have 20 is what the circle takes up, and the whole side is 30, that means there's 10 left to be split evenly. 5 on this side and 5 on this side. But here there's a split. So you split the 5 in half, 2.5 and 2.5. 2.5 and 2.5.
Oh.
Okay? And that allows me to get the rest of my areas. Pi r squared over 2, half of a circle, gives me the 50 pi there. Now I can go ahead and get the front face. It's 600 plus 25 plus 25, so plus 50, plus 25 plus 25, plus 50 pi. Okay? And I'm going to do that in my calculator. What is 50 pi? So I'm going to do 50 times 3.14. It's a crazy problem. 157 plus the 650. 807. So the front is 807 and the back is 807.
How did you get the numbers for the tiny piece, like the 10?
The diameter of the circle is 20. And then, but the whole length of the box is 30. So that leaves 10 left. I split it evenly on the left 5 and on the right 5. That makes up 10. Then this is split, and I assume that it's split evenly. 2.5 and 2.5 make up the 5, and 2.5 and 2.5 make up the 5 on the other side.
So...
But wouldn't it be 10 on each side?
No, 10, 20, and another 10 would be 40.
So...
Yeah, get your math.
Look, the radius is 10 of the circle, but the diameter of the circle is 10 and 10. It's 20, which only leaves you out of the 30. It only leaves you 10 left total. You must split the 10 evenly on both sides of the circle.
Yeah, it's 30 minus 20.
Yeah, so 5 and 5. 5 plus 20 plus 5 gives you the 30 here. Okay.
Oh.
Wait, Mr.
How did we find that the diameter was 20?
Because the radius is 10.
Radius times 2.
How did we know the radius was 10? Because the whole distance to the top is 30, and the circle starts at 20. So which means if we assume that that's a half circle, then that radius is the rest. It's the 10. If the radius is 10, what's the diameter? 20. So that's why we got the 20 there. That only leaves 10 left total, 5 on each side. Okay? Now I say,
Mr.
yeah.
If you can go ahead. I'll ask it after.
Wait, should we find the front and back first?
I have the front and the back now.
Yeah, but like, shouldn't we find it first, because then we would multiply the perimeter by the length.
It does not matter when you find it.
Mr. Rosenthal.
But then you can't multiply the parameter, or actually, I guess you can.
Mr. Rosenthal.
Yeah, we're doing it and everything's fine so far. Yes.
So for the top, would you have to find the lateral area of the cylinder?
Oh, wait on the top. Any questions so far about bottom, right, left, front, and back?
Yes. I have a question.
Mhm.
So, why did you add up 625, 25, and 50 pi? Like, what? Like, where did?
You look at this object from the front. You get the composite figure where you have this big rectangle, but you have also these little rectangles above it, and you also have the half circle above it.
Wait, is the half circle 50?
50 pi.
Okay.
We got that with pi r squared divided by 2, because it's only a half circle. Okay?
Okay. And why did you add those up though? Like,
Because you need the whole area of the front of the figure.
oh, okay.
Got it?
And what are you gonna do with the pi? Are you like,
I
because
already used it. Here I did 50 times 3.14 plus this gave me 807.
Oh, okay.
What's nice about this problem is that there are no decimals anymore. So I'm keeping the decimals out of the problem. Okay, any other questions? I actually think the side is just as difficult, or the front is just as difficult as the top. Okay, let's look down now from the top. What do we see? This is what I see. You're going to get this. You won't see this if you're looking down on it. Okay? Right? And then you get this. Oh, but we're missing something. This would almost be the answer. Okay? There's another component to the top.
Isn't it the?
There's the inside lip that's sticking up. So I'm going to have to show you that by going up here. Hold on, let the screen adapt to the brightness. There we go.
And you have to also
If you
count.
look up here, I don't know if you could see,
Yeah.
there's inside lip. You need to get that area. That's part of the surface. That's the part that is the extra kicker there that you can't forget. Somehow write that in your notes. Somehow indicate in there, like if you had this printed out, that would be easiest. If this was already printed out, then you could actually draw an arrow right to that. Don't forget this area there. Those areas are rectangles though. They're not difficult to find. Okay, they're 10 by 50. Okay, so on the side, I'm gonna put those extra inside rectangles. The ones that go up and down like that. Okay, this is the top. The top is the most complex. Okay, so the dimensions though are gonna be easy. This one is 2.5 by
Mr. Rosenthal,
50.
you are like the camera. We can't see.
Oh yeah.
What's going on down there?
Okay, so we know that these little ones are 2.5 by 50, each one of them. 2.5 by 50. Okay, what are these rectangles that are going up? These vertical rectangles that are in the inside. Okay, I'll let you look at it. So you guys can see my mouse, right? See my mouse? What are the dimensions of this dark gray rectangle that's going up and down? It's 10 in height and 50 across, right?
Yeah.
One on each side. Okay, so I'm gonna go back to mine and label those. Isn't this problem, it's pretty tricky. 10 by 50, 10 by 50, okay? And then we've already found that, and on the back. We already included that area when we did the front. So really, we want the lateral area here. We want this of the cylinder, of the half cylinder. So you need the lateral area of a half cylinder there. So the lateral area of the cylinder is PH. And we want it over 2. Crazy problem. I'll give a ton of points if you guys can pull this one off.
Oh.
Okay. The perimeter is the circumference. It's diameter pi. Well, we know the diameter of the circle is 20. There's your P. the height of the cylinder is 50, and there's your lateral area. But you want half of that because that's not a full cylinder. We divide by 2. This gives us, let's see, 500 pi. Okay, so 500 pi. I'm going to start labeling them all now. 2.5 times 50 is 125. Each of these are 125. Okay, and I like this labeling method. It's organized. This is 500. This is 500. Okay, so the top is adding these all up. So this is 250 and 250, 500, 1,000, 1,500 plus 500 pi. 1,500 plus 500 pi. There we go. Now, 500 pi. And that's going to come out, if I use 3.14, there won't be any decimals. 3.14 times 500 is 1,570 plus the 1,500. And I now have the total area of the top. There it is.
So, Mr. Rosenthal,
Huh?
did you add the 1,500? Where did you add that from?
By the way, this will be the last problem. We're going to carry on into tomorrow, and then your test is going to be Monday. Everybody? All right, so that we don't rush this. You give you a lot of time to get your notes together over the weekend. Okay? So go ahead. What was your question?
So, where was the 1,500 from? I know that we have it on the bottom right, left.
Which 1,500? Tell me a color that you're looking at. The brown?
Yes.
It's if you add up all my brown numbers.
Oh, okay.
Aren't we supposed to add all the areas?
I'm not done with the problem.
Oh, okay.
I'm taking questions up until this point.
Oh, sorry.
No problem. And you can almost add these
And
up.
then the area of those two little things that you've drawn with the 500 in the middle, that's the area, right?
That's the area of the vertical rectangles that are on the top.
Yeah, that's what I'm.
Now,
And
did I miss any area? Is there any area of this thing that I didn't cover?
what are it's 50 and 10 are the dimensions, right?
Of those, yeah. 50 and 10.
Yeah, okay.
You covered everything, I'm sure of it.
Yeah, I'm pretty sure I got every piece. If you leave out one piece, you get the problem wrong. But the good thing is the one on your test is exactly the same object. So here's your roadmap. Different numbers, same object. You have to understand it, though. If you don't understand what you're looking at, you can't follow your roadmap.
Wait, Mr. Rosenthal, hold on. Let me just.
While you're doing that, I'm going to add these all together. Okay, I got 3,070. This is 4,500. I'm going to add 4,500. Plus I don't want that 600 there. No, that's part of that. Okay, I've added up top, bottom, right, and left. That's why organizing. If you don't organize, you're going to have a problem. Plus 807, plus 1614. 9184.
What was the
And this is square millimeters. This is your total final answer. If you guys can get to the final answer on the actual one, you will be rewarded.
Will this be a bonus question?
It'll be a question. Don't feel bad if you don't get it. You can still get over 100% towards your grade if you miss this problem. Probably.
Is this like 5 points?
I don't know. I have not determined the point structure. It's a tricky business trying to get the right amount of points. But anyway, we're in office hours now. Dismissed. Well done.
Wow.
That was monster problem. All right. I hope you had fun with it.
I did.
Yeah.
I took a screenshot so that I can remember this. And I also copied down in my notes.
In the bottom right, where did you get that 25 plus 25?
So those are these little rectangles above the main rectangle, and
That's
those
the
were
total
2.5.
area of both of-
Those were 2.5 by 10.
So 2.5 times 10 and 25.
25, yeah.
Rosenthal, what's the total?
9184.
So the 25 was the area?
Yeah, 2.5 by 10 is 25.
I honestly feel like we should all get it. It might just take a while, but
All you have to do is make one wrong calculation, and the test has a limited time to it.
yeah.
So
It'd be kind of funny though if like
I am right now thinking about doing a pick 10 problems type thing, and like telling you how many points each one is. Maybe I might do that. Okay, and I'll have next to the number maybe how many points it's worth. And it's basically a free-for-all. In the time given, how many points can you get? So I might do something like that, where you can go after the more difficult problem, but it'll eat up more of your time.
Oh, so you can get more points from the difficult problems, but it'll take longer.
Right, like the quick ones will be 1 point. And this one, yeah, I can make this one, if I think this one takes 5 times longer, then I might get 5 points. What I would hate to do is make it too tempting, and then somebody doesn't get it at all, but they spent half an hour on it. I don't want that to happen either. So it's a tricky business.
Yeah. It'd be kind of funny though if you got this problem, if you got the number right, but then you forgot to put the unit of measure.
Well, I probably wouldn't count that against you.
That'd be terrible though.
Yeah. It was a monster problem.
Yeah.
When I looked at it, I thought, am I going to be able to do this problem?
I don't know if anybody else has any other questions. So
Anybody have questions?
I was just waiting if.
Thank you.
You bet. And you know, tomorrow we're almost done. So 15 through 18. So we have 4 problems to do tomorrow, and then we can go back again and go over any other problems again. I need to pick up a new set of markers.
Continuing my question.
Do this problem again.
To find the area, wouldn't you have to do the 50 times the 10 on those tiny ones?
On over here?
Yeah.
I did. That's what you see in brown, 500 and 500.
So you did the 50 times 10 for both of them, then you added it with the
other things. Yeah, 500, 500. This comes out to 500. So that's what explains the 1500. And then the lateral area that goes over the bump is 500 pi. And then I multiplied that by 3.14 and added it to my 1500 to get the top.
Wait, Mr. Rosenthal, couldn't you also do the surface area of the cylinder so then you didn't have to account for
Yes.
it on the
Yes, but then I would have to take that out over here. Either way, you're going to have to do that calculation no matter what. Now, if you're counting it as part of the top, then that's a difference. You know, it's how you're looking at it. If you want to look at it that way, that's fine. Okay?
Mm-hmm.
That is the most difficult problem on the test, I believe.
So many. It's like if you just take someone that doesn't know what we're doing and then you prop them in front of the computer, they would be extremely confused.
Yeah, but if you can do this, you have to understand it pretty well to be able to do it. Even if you are following a roadmap that you made for yourself, it's still like, yeah, if this is not an easy cheat sheet to follow unless you know what we're doing with these numbers. How are you going to know what numbers we used? You know.
Mr. Rosenthal, what did you say was the hardest part of this problem?
It's the complexity of the problem.
Oh yeah. Okay.
Any one part of it is not difficult. Making sure you the hardest part, one of the hardest parts is covering pictorially every piece and not leaving anything out. That's one of the hardest parts. How do I make sure I don't leave anything out? Organization. If I'm painting, you wouldn't forget if you were painting it. Why not? Because if you were painting this wooden box red, you would obviously see, oh, I didn't paint that part. It would just show up. Visually, you would see I didn't paint that. but you have to be able to account for it when you're not really painting that object.
It's all about perspective.
It is. It's a perspective issue.
Thank you.
Uh-huh. Yeah, if I was painting this, I would see, oh, I forgot to paint that part.
Yeah.
Yeah.
Why did you make 2 pieces on the?
Here.
Yeah.
Because that's
You
the
have
side.
two internal vertical
No.
angles.
In the other drawing, like next to it, like to the left, like directly to the left of it, in that drawing, why did you put it in multiple pieces?
Because one's higher and one's lower.
Yeah, this one's higher up than the inner one. This is dropped down lower.
So are those like the 2 sides of it?
Here, let me show you.
Because there's.
So
like,
look here. See the top of this as the mouse is going over it?
Yeah.
That's one rectangle. That's 2.5 by 50. But then drop down in here. There's another rectangle down in there.
Jonathan, also you can think of it as like the drawing that we first did for the front and the back. That's basically.
Oh, I understand. Okay, I understand what you're saying.
And then look on this side. There's a little rectangle down here in this little ravine. It's a rectangle.
So
like
wouldn't you do 50 times 10 times 50 times 10 and then 4 times? Because those are the exact.
Yes, you can treat that. I didn't want to make it more complicated than it had to be. But what you could do is you can then use the commutative property here and take all 4 of these rectangles and put them together as one rectangle.
Yeah.
That
and then you could just.
Yeah, that rectangle would be 10 times 50 would be 500. That's actually how I did it the first time. But in explaining it, I wanted everybody to account for every piece of this. And I felt that if I told everybody that, I would lose 20, 30, 40% of the crowd on doing a trick like that. But yes, you're totally right. You can do that.
But wouldn't you also have to combine the 10 like 4 times so it would become 40? And actually, no.
No, it's 2.5 times 4 is 10.
Yeah.
So it's already been combined to get to 10. So you wouldn't combine again.
Oh. So 500 is, if you did that trick, you would get 500?
Yeah, because it'd be just 10 times 50.
So then you just add 500 to the circumference.
To the bump.
No, not the area.
Area.
Yeah, to the lateral area, right.
And that gives you 150. No, 1,500.
That gives you this here. So here you see the part that doesn't have pi are all the rectangular components.
But then how did you get 1,500 from that?
Because of those I added with it.
Yeah.
So you added extras?
Yeah, here's the extra I added. Watch this.
Basically like 50.
Oh, look, this little rectangle, you can see my mouse, right?
Yeah.
This little rectangle is 1. The one down here in the ravine is 2. 3 in this ravine. The top of this one, 4. But then look at this one on the side going up and down, the dark gray. And then you have one you can't see inside of this lip,
It's
right?
larger.
So those are those 2 extras that I have on my screen.
Oh.
Those are these. Those are these.
But then what about the outside ones?
That we already did because when we did the right hand and the left hand, we went all the way to the top.
Oh yeah, you're right.
Rectangle.
I'm wondering like if you.
And that's how you got 150?
1,500.
Oh, sorry, 1,500.
Yeah, those were 30 by 50, covers the entire right and left sides.
All you need to do is basically just plug in the amounts.
But if that was if that would be 4, if that's 4 pieces, that gives you 500, and you add 2 extra pieces, wouldn't that give you 750?
No, these 4 pieces here added up to 500.
Yes.
Then this one was 500, then that one was 500. So 500 times 3 is 1,500.
Oh, both of them individually are 500.
Mm-hmm.
Yeah, these 4 together add up to 500. 500, 500. So 3 500s.
Oh,
Then
okay.
the bump here, the lateral area here in pink, that's 500 pi. I multiplied by 3.14 and added it to 1,500 to get this.
So it's thicker than it is thinner.
Oh, Jonathan, wait, were you saying like if you take all the rectangles and you put them into 1 and then you multiply 50 times 10 because.
Yeah.
That's what you were saying. Okay. Yeah, because then you just add the rectangles that were on the inner, like the inner rectangles, and then that would be more mental rather than.
Oh, okay.
Yeah.
Mr. Rosenthal.
Mm-hmm.
I'm still kind of confused about how to solve for number 6.
Okay, let's go up to number 6. All right, so no more questions about this problem. I'm going to move back to number 6.
I know how to do
Is that the one about the ratio?
Yep.
Yeah, that was the one that we solved the proportions, I think. Yeah.
A circular cover to a septic tank has a diameter that is 4.5. So guess what I'm going to draw? Septic tank, it's a cylinder. I'm drawing a cylinder. Okay, and it has a diameter 4.5 times the diameter. So I don't know what the diameter is. I'll just label it D. But it's 4.5 times the diameter of the cover to a water well. Okay, so I have this smaller cover. Okay, and I'm going to say that diameter is little d. All right, and it's 4.5 times the diameter. So a diameter is one-dimensional. It's just a length, that's it. All right, so the ratio from the big one to the small one is 4.5 to 1. That's what it means for one to be 4.5 times greater than the other in one dimension. Are you with me on that?
So you're just comparing both diameters.
That's all I'm doing.
Okay, yeah, I understand that.
Now they start to mention area. If the area of the septic tank cover is 40 square feet, what is the square footage of the other? This is not one dimension to one dimension, so you may not set those equal to each other. So you might think we're at an impasse, we can't go further, but you can. Because if we know the one-dimensional relationship, then you can get the two-dimensional relationship by squaring this fraction.
So you can just square the diameter and you go to the next dimension?
Correct.
So does that apply to like radius too, or is it just the diameter?
The radius is the same. It's one dimension. Nice. Nice boat, Jack. So yeah, so if this was the relationship between the radii, it would be the same thing. Then the areas have to have a relationship that is the square of that. It only matters what dimension you're in. It doesn't matter if it's a length, a width, a height, a depth, a radius, a diameter, any of those are all one-dimensional. So this is a comparison problem. When you're comparing one dimension to one dimension, but then you want to get a relationship between area, then it has to be the relationship you had in one dimension squared. So now what does that give us? Squared this is going to be 20.25, and 1 squared is what?
1.
1. This has to be the relationship between their areas. It does not mean that the area of one is 20.25. I don't square the diameter, it doesn't give me the area. It gives me the ratio that it has to be in. Remember, if something's in a 1-to-2 ratio, it doesn't mean that the objects are 1 and 2. It could be 5, and the other one then is 10. One of them could be 13, and the other could be 26, right? By me saying the ratio is 1-to-2, it doesn't tell me that the areas are 1 and 2, right?
So the 20.
If I'm telling you, if I square the ratio of diameters, now I have the ratio of their areas. It doesn't mean that those are the areas. As a matter of fact, that is the area.
Oh, okay.
Okay, now you have a proportion.
So 20.25 over 1 is the ratio comparing both of the areas.
Yes.
And then the 40 over x is
the actual area of the bigger one. So x has to be a certain number so that when you simplify it, it comes out to this ratio.
Oh, okay, yeah, because I was kind of confused about how you got the proportion.
Yeah. Do you have it now?
Yeah.
Okay. And then do you remember how to solve it? cross multiply.
Mhm.
40 times 1 is 40. And that equals the other cross product, which is 20.25x. And how do you solve that? You divide by 20.25 on both sides. Then you get 1x is equal to. And then you'll know what the area of the cover is. Whatever
So
that
you like height, diameter, radius, like anything that you square goes to the second dimension if it was the first before?
Yeah, and that, again, that doesn't mean that the area becomes that number. It just is talking about the relationship.
Okay.
Yeah, it's the ratio is squared.
Okay.
All
Yeah,
right?
I think I understand it now. Thank you.
You got it. Anybody else?
This is probably the most amount of questions we've had during office hours.
Yeah, it's good. Well, you know, the stakes are much higher now because this is a review time. When the stakes get higher, the YouTube videos, the hits I get go up as well.
Yeah.
Yeah.
Like and subscribe and hit that notification button.
Mm-hmm. That's right. That's what I'm supposed to say.
Do you think anyone outside of our class is watching your YouTube videos?
I don't think so. I didn't title them in such a way to do that. Maybe after the school year is done, I can title them what the subject is about, so that if somebody's trying to learn about a particular thing, like volume of a cone, those actual words will come up when they search it. Right now it says Math 6, Lesson 12-10, or whatever it is. That no one's going to search for that.
You can also re-upload, I think.
You do what?
You can re-upload and then rename it.
What if someone has the same book that we're using and they look up that they want the answers to that specific chapter?
You're going to limit. You're not going to get any hits on that. That's not going to give you much traffic. If you want traffic, you need it more general. So when somebody's having trouble with a certain area, then when they look up, I'm having trouble with solving linear equations in slope-intercept form, then my title of that section where I taught that should say that.
That's why.
Yeah, go ahead.
That's why, like, on websites, they actually give you what they're doing, not just like the process the process in the title.
Mm-hmm.
Because then it will be like most likely the first page that comes up.
Yeah.
Because
oh, go ahead.
Let's just say, like, in Wikipedia, I don't ever use Wikipedia, but if you're looking up like a person, let's just say, Wikipedia is most likely going to be the first website that pops up, because it's just like their name.
Mm-hmm.
And it's usually going to be most search, because like, let's just say there's like a person and then you're looking at like their life or like what they've done. It's probably going to be in like a biography.
Mm-hmm.
So then you don't name your article something so random that no one's going to go on it.
Yeah. Does anybody have any more math they want to do?
Let's see. Where's my algebra? Oh yeah, Mr. Rosenthal. So on the topic of quadratics, is there anything I should learn more about over the summer? Because I might do some practice problems too.
I would just stick to, what I recommended last time is just thoroughly go through that book.
Yeah.
Yeah, thoroughly go through that book. All right.
Also,
were you thinking about taking any summer classes?
Yeah.
What were you going to take? Algebra?
I think so. I think my mom signed me up for like this. I forgot what it was called, but I don't know if it was like a college course or just like a course on algebra.
Mm-hmm.
And maybe geometry. Like if I get past algebra, then I can. But is there an entry? Is there like an entry test in the beginning of algebra to get into geometry?
I don't think so. I mean, you're going to need to know your algebra, which you know a lot of it already. You're going to need to know it to do half the geometry is going to be using algebra to do it.
Yeah. So I know like Ryan Lee, he got into algebra pretty late.
Mm-hmm.
So
what are you looking to do? Are you looking to join that accelerated group?
I was just wondering because Mr. Canals, I think he was like evaluating him or something like that.
Are your goals to join that accelerated group at some point to get on their track?
I want to take one step at a time. I'm not trying to go ahead. I just want to see what offers there are if I fully understand it, because sometimes doing the course over again can help you better understand the subject.
And you're going to get it from another teacher. They have a whole nother perspective on it.
Yeah.
Yeah. So when you get it from another perspective, you can get it deeper. But that's always your option. Your option is always to stick around in a content area and go deeper, or say, well, that's enough of that. Let me move on to another subject area.
But it's like you rather want to go deeper and understand it than only get like a little snippet of it.
And it's not. There's a lot in between. It's a spectrum, where you're, you can be in many different places along that spectrum. You can go to depth. Give it a value of 9,172, and then you haven't got a lot of breadth. You went really deep, so your breadth is only 105. Or you can pull off on your depth and pull it back to 5,102, and now you give a little bit more breadth because you go to more topics. So then now your topics now are at 2,000, or whatever. You know what I mean? So it's an adjustment, and it's an exchange of your time and your energy, right? Where at this time, what are you doing right now at any given time? What are you doing with your time and your energy, and what kind of knowledge are you putting into your brain? It's always a trade-off. Whatever you're going to choose, that's called opportunity cost in economics. Whatever you choose to do with your time and your energy, then everything else you're not doing is the cost of doing that. All the other things, you could have been learning a language right now. Right now, you could be learning the first word that you want to learn of German or of Japanese, or right now you could be doing that. Instead, you're doing this, right? Yeah. All right, so everything you do, you're not doing other things. So it's always a trade-off.
My dog's barking now.
Yes. All right, well, I think that I will see you guys tomorrow then.
Okay.
Okay?
Okay, bye, Mr. Rosenthal.
Bye. I'll see you tomorrow.
Thank you.
All right, bye.
Bye.